Charles' law states that volume is proportional to temperature. What things must be true for this to work? So mathematically, we can say that means V is proportional to T. But when we look at the ideal gas law, PV equals N RT, we can see here's V, here's T. Everything else must be a constant for this to be related. In that sense, maybe a way of mathematically stating this is I could say, let's solve for V and then rewrite this as maybe NR over P times T. And as long as the thing here in these parentheses that I'm going to add in now, as long as that is a constant, then I can say that the claim that volume is proportional to temperature is correct. Well, N is constant, R is constant, but P doesn't necessarily have to be. So when we're being asked what things must be true for this to work, the statement is that P must be constant. So I'm just going to say P is constant in order for this to be true. In other words, in order for Charles' law to be true. One thing that's added here in the answer that I maybe should emphasize again is that in the ideal gas law, the temperature must be measured in Kelvin. That's a pretty common pitfall, is to forget that that temperature T really must be kind of the physical temperature T as defined with the Kelvin unit. In other words, we can't have an inappropriate zero there. Negative temperature really actually doesn't make sense with the way things scale. In that sense, like if you had a negative temperature, would that mean that you'd have a negative volume based on Charles' law? So that kind of reminds us, yeah, that doesn't really make sense. So that's why you have to be in Kelvin for things like this to make sense.